less than f of x minus 3 less than 1. Agreed? Now, writing this backwards in terms of an absolute value, how will it read? Exactly this, right? Rewriting it with the absolute value is going to come back and read just like this, because these say the same thing. The distance between our function and 3 is at most 1.
Is this like proving two trig functions are equal to each other? Like
Proving what?
two trig functions are equal. Is this kind of that concept that you have
No.
to show?
No, not exactly, no. So what we've just shown is that as long as I contain x to be a distance 1 away from 2, right, where the limit is heading, where x is heading towards, as long as this x is only 1 away from 2, this is at most 1 away from this. That's what we've shown. Now we're going to pick another value, a value closer to 0. We're going to do the same thing again so you get the idea better, right? Pick a number smaller than 1, which is closer to 0.
0.5.
Okay, chosen, 0.5. So, 0.5 it is. Rewrite the same thing, we do the same thing again. I don't think we got it at all. 0.5. Can you find a delta? That is, can you tell me how close x should be to 2 to guarantee that these heights here are only a half a unit away from 3? The function value is only half a unit away from 3 now. So all we've done is constricted this thing. We now want to guarantee that these are half a unit closer. So the purple lines would be at 2.5 and 3.5 now. And I want to guarantee that our function is trapped in there. How do I guarantee the function? What delta do I pick to guarantee the function is trapped in there is the question. So 0.5 seems like a reasonable guess. Okay, let's see if you're right. If we bound the distance between x and 2 by 0.5, does that guarantee the function is no further away from 3 than 0.5? Since the slope is 1, it seems reasonable, right? Okay. Well, let's see. Let's just write it again here. So if delta is a half, then what are we saying? We're saying that x minus 2 is bound by that delta. It's bound by a half. If we rewrite that without the absolute value notation, it'll be negative 1/2 less than x minus 2 less than a half, right? And now we would like to say something about the function x plus 1 from this expression here. We're really trying to go from this little expression here to say something about the function expression, right? So x minus 2 is sort of what this is talking about, x getting closer to 2. And we want to change that to be the function x plus 1, which we're talking about. So again, I should add 3, right? So if I add 3, what's negative half plus 3?
3.5. Negative 3.5.
Give me a fraction. That was negative 2.5, right? What, 5 halves? Negative 5 halves?
Yeah.
Okay, negative 5 halves less than x plus 1, less than our function, less than, if I add 2 to that, sorry, add 3 to that, I got 7 halves? Is that right? Oh, sandbox days, I've forgotten you. All right, so there's our function, x plus 1, but I want to say something about how it's related to the number 3. How close is it to 3? So I need to now subtract 3 from this expression, right? This is f of x.
Wait, why did you add a 1? Like, why is it
I
x
added
plus 1?
3 to the whole thing to get the function we're talking about, which is the x plus 1 function. Because I want to say something from here, right, about how close x is to 2, to say something about how close our function is to 3. So I need to change this to the function.
Wait, if you're adding 3 to everything, right?
Yeah, I added 3 to each one, yeah.
So why is the left side still negative?
I have no idea. Thank you, Cornejo.
Okay.
All right. So now I need to subtract 3. So we subtract 3 from 5 halves. What do you get? Back down to negative 1/2. Is that right?
Yeah.
Okay. Negative 1/2 less than f of x minus 3. 3, the expression I'm trying to get to that, less than, back down to a, what, half? Okay. And what does this say? It says exactly that, right? We have guaranteed that as long as we contain x to be within a distance 1/2 from 2, that is, from 1.5 to 2.5, as long as it's trapped in here, that's going to guarantee that our function is trapped between 2.5 and 3.5.
Wait.
Yeah.
Okay, so from the second line where it says x plus 1, you subtracted 3 from the whole entire line?
I subtracted 3 from the whole thing to make it look like this.
Oh, because x plus 1 is f of x.
That's
okay.
right. Exactly right. And once you have the same number on both sides, but this one is negative, then this wraps up into this sort of absolute value of inequality. Carrie? Absolutely. This is unique to this case because the line has a slope of 1. That's what's making it work out so nice and why I picked it, so we didn't have so much trouble with this, right? But there can be trouble conceptually. It's not the clearest thing in the world the first time you've seen it, that's for sure. All right? Now, I would like to pick something even closer to 0 than a half, like a quarter, like a 16th, like a 32nd, like a 1 over a billion, right? I want to get as close as I can to 0, right? And that will, in a sense, show me that as long as I push the distance of x and 2 between them down to very close to 0, right? It's going to squeeze the function values down to being arbitrarily close to the number 3. And that's what's telling us that the limit of the function is 3 as long as x is going to 2, right? So that's why the definition here says for every single epsilon, not Rosellis 1, and not whoever said 2, not Lou's 2, 1/2. Who say 1/2? Who said 1/2? Who chose 1/2? Roger, you chose 1/2 here? You chose 0.5? Rosellis 1 and Raja's 0.5 is not sufficient for a proof that the limit is actually 3. All we've done is found a bound for the function. We know the function is trapped between 2.5 and 3.5 whenever you pick delta to be 0.5. That's all we know. Okay? To show that this thing is actually heading towards the number 3, then you have to show that for every single epsilon, right, no matter how small or how large, every single positive number, you can find a delta that makes that happen. So here's where the proof comes in, right? So the way it works is the delta is based on the epsilon. Epsilon is left as a letter in the proof, and you are trying to find a delta which is dependent upon epsilon, the letter epsilon. So delta will be a function of epsilon. You got me so far or not?
Wait, can you write that down? That, like, what it would look like delta would be a function of epsilon?
Delta is a function of epsilon.
Okay.
No, I'm just kidding. I'm just kidding. Let's just do a problem.
I know, I mean, I just wanted to see what this looks like.
You'll see. We'll just go through this one right here. We now have a hunch, based on what we just did, and this beautiful picture I've drawn, that the limit really is 3. And now we're going to go through the formal proof to show that it is so. All right, so we have to follow this definition. Just like we did for continuity, we had to follow the definition for continuity to either prove or disprove certain things. We had to follow the definition for limits in this section, right? We don't get the ease of just like plug and chug like we did before, right? This is using the definition to show limits in the most formal way possible. So